Mike Awadallah.
I'm Kylie Stuer.
So basically the main problems that we wanted to address with traditional night lights is that they use incandescent light bulbs. They consume a lot of power and they'd be really hot to the touch. Many of the night lights that are used today are switch activated. So there's a lot of time where you're in the dark looking for the switch, trying to turn it on and off. And many times they're really easy to leave on. And some night lights automatically turn on in the dark, and this wastes power if nobody's in the room or they're asleep. And lastly, we found that night lights mess with the natural melatonin release process in children. Our idea proposal is that we want to design a motion censored night light that will turn on only when movement is detected. After movement, the night light will turn on and stay on for about 3 minutes. And after about 3 minutes, the night light will slowly fade out and completely turn off. One of the ideas that we kicked around during the project design was possibly having a certain window that the night light would operate, possibly like 7 p.m. to 7 a.m. For components to build the night light, we first started with a motion sensor. It was a passive infrared sensor developed by Parallax that was distributed through DigiKey. It cost about $15. And the second main component for the design was the LED light. We chose an RGB LED light that was developed by Adafruit and also distributed by DigiKey that retailed for about $9.99. All the other components that were required for the project we had before, mainly the PSOC board is what was driving the whole project, and that already came with the class at the start of the semester. So in total, the entire project cost about $25. Our original timeline, for week 1, we kind of just wanted to start with simple design, requirements for the circuit and just some preliminary testing on some of the pieces. For week 2, we wanted to start writing our code that would be able to display a message on the terminal, and then start kind of assembling our circuit, getting a rough idea of what it would look like. Week 3, we kind of ended up editing a previous project that would actually help aid us in building our current project. And then week 4 was just tying up any loose ends with the project and start putting together the final report. And then for week 1, the original goal was testing all the hardware components and verify that everything worked. These are mainly the passive infrared sensor and the LED lights. What we actually ended up doing was we had to skip ahead to the week 2 tasks, and we began configuring the PSOC project and writing code since none of the components had come in yet.
So for week 2, we still didn't have our components, so we kind of continued working on the software side of things. What we did was create a simple version of our project where we substituted the PIR sensor for a push button, and we had that kind of working as pushing the button basically served as our motion being detected to verify that the software we had built in week 1 was working. So we got all that. We kind of verified that everything we had done on the software side was at least functioning. For week 3, we got our components in, and we basically just tested that all the hardware worked. One of the important things that we tested was that the sensor we had worked in the dark, so that our project could actually be used as a nightlight. For week 4, we had pretty much finished up everything that we needed to do. A lot of week 4 was just figuring out the timings and making sure that everything was working smoothly. And then here we have a little video of our project working. You can see that after motion is passed in front of the sensor, that it turns the LEDs on, and then after a brief moment, they turn off. For like an actual practical use of this project, the amount of times that the LED would stay on would be a lot longer, but for like demonstration purposes, we shorten the timing. Also, the sensor works from farther away, not just right up close. But we just had everything up close so you could see what was happening. And that's our project. Thank you.
Thanks.